So the title of the talk, as it has been said in the introduction, is Dataset Search, helping the world discover the data they need. And this was work that we have done in the context of an EPSRC research grant that finished at the end of January, EPSRC being the main funding body in the UK for fundamental research. So data stories itself, the idea came to us a few years earlier. To be more precise, it was the summer of 2016, which was quite a momentous year in political events. And I just want to take some time to establish the context or the mindset that we had when we set out to define our research agenda. This was one of the quotes. This was one of the things that we wrote in the bid when we were asking for funding. One of the interpretations of the EU referendum result and the rise of Donald Trump in the US is that we're now living in a post-truth society. And this world is one where content shared on social media and information that is obviously and blatantly fake are more shared and more trusted and influential than numbers that come from official sources, extensive research, proven expertise. And in this world, in which we were living back then, and we're certainly still living today, scientists, statisticians, analysts, and journalists, so professions that work extensively with data and data analysis methodologies must find new ways to bring hard factual data to the public. And we continued by claiming that to counter some of the effects in this post-truth society, we need to come up with ways for data to entertain, just like any other form of content that is shared online. So data must entertain as well as inform, excite, as well as educate. It must be built with social media sharing in mind and become part of our everyday activities and digital interactions with others. So far so good. But what does this actually mean for a computer scientist? And at this point, I'd like to take a minute to tell you a little bit about my research background. So I am a trained computer scientist. My specialist degree has been focusing on data and knowledge bases. And then I moved into an area called knowledge engineering, where it was very much about the processes, methodologies, and tools we have in place to help people encode information and knowledge formally in a way that computers, in particular AI systems, can understand. And from this experience in knowledge engineering, I have realized very early on, already during my PhD, how important human and social factors are for technology. So I have then moved on as a postdoc and then later on as faculty to look at human and social factors in various areas in technology design, in particular in scenarios that are very data intensive. So I have a background both in computational methods and formal methods in computing, and in user-oriented research, and the approach that we have taken in data stories is a reflection of this. So to help people publish and communicate with data in a more entertaining as well as informed way, we developed theoretical frameworks as well as technologies and methods that are inspired by art, games, and storytelling. We also ran empirical studies where we have examined the impact of various methods that localize, topicalize, and make data more shareable on public engagement. And we've delivered software, so software tools as well as guidance to help different professions communicate through data in novel ways. So some of the results of these projects have been software and algorithms. Some have been human-computer interaction resources in form of templates, in form of guidance, and toolkits. So in data stories, we had two main themes. The first one is going to be very brief, and then I'm going to move on to the second one, which is dataset search, the topic of the talk. So starting with this scenario where most of us we are browsing online, we are engaging in social networks, we are reading newspapers. In all these environments and settings, we are increasingly being confronted with data. These could be statistics that are shared in a tweet, or data journalism pieces, or more recently, as of 2020, graphs depicting various types of statistics around the global pandemic. So I don't know how it is around the world, but in the UK, many government press conferences now consist entirely of slideshows with charts. So there's data everywhere. Data has become the medium to communicate important messages, not just to scientists and other expert audiences, but to the public. So we wanted to look at ways to communicate, to represent data in different ways. So we all know the traditional ways to communicate data. Say you open a spreadsheet in Excel and you look at it. You might also be able to generate a chart if you want a more compact visual representation of it. But is there anything else? And the answer is yes. Quite a range of representations that human-computer interaction researchers and data designers have looked at. And we specifically focused on games, casual games, and on data artwork. So for casual games, the idea is that this bar chart with the red dot on the top is an example of this. So this is an example of a casual game whose aim is to teach people the values of this particular data set. So I think this is a data set about official statistics about the economy of a particular country. So the aim of the game is to move this red ball from the left of the screen to the right of the screen by manipulating the height of the bars in the bar chart, and you can exchange a bar for another. So each of these bars represents attributes in the data set. That would be columns in your spreadsheet. So for instance, if you want the ball to go down, you would need to pick an attribute that you think would have a lower value than the one before it. And in this way, you are really thinking about the values, value ranges of those particular attributes of the tabular data set in a different way than if you would be inspecting those values in a spreadsheet. And the idea then is to see whether engaging with that tabular data set in this way, in this playful way, is different than perhaps looking at more traditional static visualizations or indeed at the raw data. And this is not the only game like this around. There's several of them. We have developed some, other researchers have developed some, and we have also looked at methodologies to evaluate and compare this approach to more traditional ones. The other thing that we have done is around data art. So these are much more complex, bespoke projects where we have engaged with artists, digital artists, visual artists, artist collective, who, unlike us scientists, have very different approaches to communicate with the public. And we have commissioned data artworks, representations of data sets about cities, about economic development, about clinical drug research. And we have built these artworks that present the data in different ways. For instance, the screenshot in the middle is a piece called The Mood Pinball, which was developed in collaboration with Birmingham Open Media, a gallery in Birmingham in the UK, where the idea is to take a data diary that has been created by an artist that works in that gallery, a neurodiverse artist that has been logging information data about their impressions around air pollution, noise levels, and many other attributes that are collected in smart cities datasets. And we have presented this dataset, we have mapped that dataset and how the artist feels depending on those levels of pollution in the city. We've mapped it to movements in this pinball. And when someone interacts with the pinball, and the ball is moving from one part of the other to on that screen, you get a sense of the changes in the values in that data set in a different way than if you would perhaps play a game like the one that I've just described, or just looking at the data itself. And I could give you a full presentation about data artworks, but that's not really the subject of this topic. If you look on the Data Stories website, you'll have more publications about this, videos, presentations, and so on and so forth. The other important piece that we've done around how data could become more entertaining in more, let's say, private general context is we've analyzed the relationship between data and social media, and there we've picked a particular data representation, which is charts, because they're increasingly being used in all sorts of contexts, not just by experts, but also as a marketing tool for brands to disseminate information about themselves. So we wanted to understand whether there is anything in how a chart is made that makes them go viral, just like any other type of information goes viral. And for that, we've built deep learning, a neural end-to-end system that looks at posts on Twitter. And if there is an image in that post, it tries to guess whether that's a chart or not, or something else. There's examples of charts and non-charts here on the slide. And then if it thinks it's a chart, it classifies it based on its type, bar chart, pie chart, line graph, and so on and so forth. And then it goes on and uses information diffusion, information propagation models, which are known from social media analysis, to try to predict, based on attributes of the author of the post, the content of the post itself, and the graph, how many likes and retweets that post is going to achieve. And the idea would be that we give back, based on what we learn from this analysis, we can provide guidance to data journalists and other people working with data on how they could make their message spread faster in these environments. The second theme, so this first theme was really about all of us experiencing data online in various ways. The second theme focused really on data professionals, on people who work with data as part of their daily jobs. And one of the common things that you do if you're a data journalist or a researcher or an analyst is that you have your own data, but more often than not, you have to search for other data sets. This is really, well, at least 5 years ago when we started working on this, this was a very new area that is rapidly developing. So the research that we've done was very much exploratory at the beginning. There were lots of questions that we needed to look at, from how who searches for data and in which contexts, what sort of queries, keywords people use, do they use web search or something else? what sort of mechanisms should we put in place to present the results? Because what you know from web search and document or image search doesn't really apply to searching for spreadsheets, for example. How do you measure success? So when do you know if someone downloads a dataset, is that successful? Are there any other ways to think about this, and so on and so forth? So there's all sorts of questions. If you have learned about information retrieval, perhaps in your studies already, there's very similar questions there. But the difference, the challenge here was that we were in a new domain, which was datasets rather than documents. So it is typical when you explore such a new field to start by talking to people and trying to understand the current situation, and we've done that. So one of the first works we've done with the human-computer interaction PhD student was to interview 20 practitioners, 20 people who work with data sets as part of their daily jobs, and we've tried to understand, what sort of tasks are they trying to complete. How do they go about searching? Is it about finding a particular data set, or is it about meeting a particular domain objective? What sort of tools they use? Do they use repositories with data sets? Do they ask people? Do they use freedom of information requests towards data publishers? How do they evaluate the data sets that they find? And what are the sort of attributes when they scan data sets that give them more confidence that this is the resource that they need? Complementary to that, again, typical for a research endeavor where you're exploring an unknown areas, we've done some empirical research. So dataset portals, for instance, in government, but also in science, publish tens of thousands of data sets openly, and they also have logs of user activity where they can see who visited that portal, what sort of queries did they write when they were looking for data sets. So those sort of activity logs give you an understanding of people's behavior in searching for data sets in a different way than interviews. So we had access in 2018, we had access to 2.2 million search sessions from 4 different open government data portals. And we've done a quantitative analysis to try to see what sort of keywords people use. And we've realized it's mostly predominantly these sort of keywords include the time frame for the data and the location for the data. We've also realized that there's at least 2 types of users who search for data sets: those who start on a web and are looking for something, and others who know already a portal and start their search there. So they're much more bound, much more related and relevant to the publisher itself. We've done a similar type of analysis more recently. In fact, there's 2 reports that we have published. The last one should be coming out next week, where we have looked at a portal called the European Data Portal that offers access to 80 different data publishers and more than 1 million open government data sets to understand search behavior there. And indeed, they confirmed that dichotomy of users, the web search ones and the ones that start the search natively. Also empirically, we realized that because of the way search traffic works and the relationships between web search engines and portals like the EDP, it's really important for ranking by search engines to have very good dataset preview pages. So when someone finds a dataset, there is a link to the dataset as well, but equally important is the HTML page that surrounds that link that presents the dataset to the user. And also for ranking purposes, it is really important to not just present the dataset in isolation, but to link it to additional content. For instance, a data story that presents the data, or an article that explains how it could be used. We've also realized that this is a huge area of research. So there's the 2 pieces in red are the ones that I'm going to talk a little bit about in this presentation. The Other ones are still subjects of very intensive research. So let me just talk a little bit about how searching for dataset works. So how does search work in general? You have keywords that you're typing into a search interface, and then the search engine is taking those keywords and matching them against an index, and then retrieves results, ranks those results, and presents them. It's not very different in dataset search, with the exception that at least for now and for various privacy and other technical reasons, the search for datasets doesn't actually look into the content of the datasets, because very often a search engine doesn't have the rights to scan the content of those datasets. Instead, all it does is mostly just looking at metadata. So this is a structured record that could be expressed in formats like dcat.ap or schema.org. That is a markup for the dataset itself that says, well, the author of the dataset is this, it has been published this and then, it's formatted in JSON, and a few keywords about the domain. So it's a much more restricted representation of what the dataset is about, and often incomplete and outdated. And that's one of the reasons why dataset search is much harder to do than document search, where at least for public documents, you have access to the text and you can use different bags of words or encoding models to have much richer representations of the content. Also, at least until 2 years ago, we just didn't have enough interaction data available to use the same sort of machine learning models that web search engines use at scale to understand really what is relevant and not in each data set. Then regarding result presentation, we've also seen in those empirical studies of interactions and activities of users on portals and in web search that it's key to think about how you present the results. So in a regular web search scenario, you have a result snippet, which is, you probably have seen this many times. It's, it's a 3 lines, 4 lines summary or representation or preview of the document that you are going to click on. What is the equivalent of a snippet for a data set, for a spreadsheet with 60,000 rows? So there's various different representations. Some of them have been more evaluated and tested than others, but our research has shown that it's important to have not just the metadata, but also a textual summary to have some details on how the dataset was collected and perhaps used in the past, as well as much information as possible up front about its quality, and possibly some tools that you can immediately try out the dataset and see what's inside without having to download it and install specific machinery on your local machine. This is why then in our research we started looking at these sort of representations, and one piece we've done in 2019 was to try to answer the following questions. Given a data set, how, if I want to write 100 words text summary about that data set to present it to someone, what would that summary need to contain? So sort of try to come up with the equivalent of the document result snippet from web search for data sets. And for that, we've asked students who were searching for data sets for their projects to keep a diary to understand how they search for and what are the important attributes. And we've also run additional studies where we've asked 80 people to actually write summaries for data sets, and we've analyzed those and developed these tools, these checklists for data publishers to write better dataset documentation. The final study that I'm going to bring up has been published really recently, and it is very much confirming that the importance of documentation. So the approach we've taken here was slightly different. We had access to a corpus of 1.4 million data sets that have been shared on GitHub I'm sure you're familiar with the platform, across 65,000 GitHub repositories. So like in a regular repository, you have a data set, you have a README file, you have various types of documentation. We also had access to engagement information, like the number of forks and commits and other metrics like that give you a sense of how popular a particular dataset resource has been. And we wanted to see whether there is any correlation between things that we are supposed to do as data publishers to make our data set easier to use, and actual engagement with the data set that is observed through these sort of metrics on GitHub. And we've built a machine learning model as well that is able to predict or to help you prioritize when you publish a data set, what sort of features are really important. So we were very happy to have, additional confirmation complementing the search log analysis about the importance of documentation, about the importance of text summaries, and how they can provenly make your data set more engaging for others. But we've also had some interesting findings, and you can have a look at the patterns paper if you want, about how packaging the data, so file distributions, can make it more accessible, and some empirical evidence on the impact of collocated tools. So to conclude, I hope you agree with me that we do live in a data world, both privately and professionally, and as a society, and in many settings, from social media to our own work, we need methods to help us find the data we need and then make sense of it and use it. This is all part of a much larger data literacy agenda that has huge societal implications, but it is nevertheless a critical piece where computer science, both the user-centered HCI sort and the more information retrieval, data management sort, can play a huge role. Because there's still a lot of interesting research to do around neural retrieval for data sets, around learning to rank, about how to build recommender systems for data sets, as well as understanding or continuing our research to understand how people interact with data. Thank you very much. And if you have any questions, I'd be happy to take them.